Hello, everyone. Thank you for joining me for today's webinar, where I will discuss attempting to implement Maple within the classroom in the calculus sequences, linear algebra and differential equations at Johnston Community College, as well as across North Carolina community colleges. The premise of today's presentation is that Maple is a highly effective computer algebra system. If used effectively in the 21st century classroom, enhances technology skills for students and faculty in community college level calculus courses, consequently improving success among STEM aspiring students. Pivotal to obtaining significant gains in student success in college level calculus courses are the experiences and skills of the faculty. Today's webinar outlines just some transformational teaching, technology literacy. I'll talk a bit about a TPAC model, which is used for analyzing effective technology integration in the classroom. I'll talk a bit about the Maple implementation process at my college, just a process for ongoing professional development and faculty support. And I'll share some testimonies from students and faculty, and at the end as well, an opportunity for Q&A. This quote by George Couros is a reminder of how to achieve transformational teaching using technology in the math classroom. It's important to note that creating the infrastructure is just not enough. I believe that transformational teaching and learning in the 21st century mathematics classroom using Maple begins with the instructor. So I wanted to share that, I work with a team of highly motivated math faculty at Johnston Community College. They're very passionate about student learning and collectively possess the breadth and depth of knowledge of content and pedagogical knowledge of some of the top community college instructors in North Carolina. It's important to note that, yet implementing Maple in our college has had its share of challenges, and this is no fault of the faculty themselves. The technology integration in math classroom is a challenging change process, especially for novice users. And even though I've been using Maple for several years, over a decade, I still to some days consider myself a novice. So from my experience, Maple's intuitive clickable user interface allows for a more seamless transition for the instructor. Presenting through the context of cognitive psychology, the notion of representation plays an important role regarding the acquisition and the treatment of an individual's knowledge. Using the clickable math features in Maple, calculus instructors have the ability to present many concepts through 3 representations in order to achieve optimal mobilization of knowledge. Many topics in calculus can be presented analytically, numerically, and graphically. In the first semester calculus course, proceeding a rigorous approach to limits, Maple tutors may be used to show stepped out process for evaluating a limit analytically. The algebraic process does not capture the whole picture though. Numerically and graphically, students' conceptual understanding improves by exploring the directional limits around the neighborhood of a point. So increased confidence and comfort for beginning Maple users may be achieved through what's called symbol sets, defined by Zahavi in 2 ways. One is that the awareness of that one can successfully engineer symbolic relationships which express the verbal or graphical information needed to make progress in a problem, and the ability to engineer those expressions. Also, the ability to select a possible symbolic representation of the problem, and if necessary, to have the courage first to recognize and heed one's dissatisfaction with that choice, and second, to be resourceful in searching for a better one as a replacement. So for many beginning faculty users, Maple can promote fear and stress and may trigger negative perceptions about the purpose of using the software to teach mathematics. I have identified 5 key reasons from my experience faculty may be hesitant in using Maple in their classroom. One, faculty want to be efficient when teaching their math classes on a day-to-day basis. But the learning curve varies across users, and getting accustomed to the specificities of Maple can be time-consuming. Trust is also an important factor, as faculty may fear that Maple would return solutions leading to misconceptions in mathematics. I've found that transcription errors to be like one of the #1 causes for student errors using Maple in the classroom. Thanks to the development of the Maple companion app, though, this may very well be a problem, of the past, I believe. Often using technology, in the classroom, you really ought to be a risk taker. I mean, there are, too many unpredictables, of course, to consider when using Maple in the classroom. I think many more faculty specialty using technology in math class should be more risk takers. But it's important to know that their confidence does play a role, an important role, I believe, in this process. Faculty also want to be assured that the use of Maple has a positive impact, um, on their instruction. And faculty also, want to know that what value does Maple add to their instruction and student learning. And I think these are 5 very important factors, to consider when we're thinking about the integration of technology in our classrooms. So a quote by Cook, Bell, Nugent, and Smith here suggests that faculty stress from day-to-day use of technology can be relieved through the development of their technological literacy. Um, Additionally, Husserl suggests transformational teaching using Maple enhances the technological literacy of all users, making them more equipped to face the complexities of the real-world learning environment. So allow me to share some exploratory exercises in various ways I've used Maple over the past decade in my calculus 1 through 3 courses. Um, One, it's important to know that instructors create exploratory exercises through a plethora of visualization and animation features using Maple. These foster deep mathematical thinking and deepen their conceptual understanding for students. So one particular example where students studying extrema on a restricted boundary, it allows the students the opportunity to visualize a solution to a multi-step problem. Here they can view a visual representation of the solution to see here we have a restricted boundary over a surface, and we can identify a global maximum and minimum, and then work towards achieving that particular hypothesis, I may say. Also, students, when studying curves in space, students can visualize the relationship between the Fourier vectors and the oscillating planes as they relate to the computation of torsion, which is an important topic studied in the 3rd level calculus as well. Also, storytelling. Maple instructors has the ability to bring problems to life within the classroom. And I have 3 examples to share as well. So one, this is an example of a project using projectile motions in space, one developed by a team of students, where an object is launched, above ground level, a desired initial velocity undergoes some acceleration, in addition to gravity, causing the object to drift. Students can, kind of play this problem out to address the solution in a more dynamic way, because that calculus is far more dynamic than it's often presented. So I think this is a great tool that students, often really appreciate. Also, students can look at applications to their partial derivatives, specific to the chain rule. Here we can visualize the rate of change at which the distance between two particles traveling on an elliptic path are changing prior to solving the problem using a rigorous calculus technique. Also, students can use applications of the gradient and directional derivatives to find just the path or optimal path the particle moves along a surface in space. So this just gives some examples of the dynamic ways topics are presented in some of my calculus classes. Additionally, we can, Maple, we have the ability to make the math tangible. So Maple also has the ability to export files to STL. It's a stereolithography file, and the instructor has the ability to help students see, feel, while experimenting with mathematical concepts, while introducing students to 3D printing. So this particular animation just shows using the series of commands, we can provide this export. In the past, we've 3D printed these particular objects where students realize math can be tangible, which I think is a powerful concept in our math courses. With Maple, teachers have the ability to increase the global awareness. Increase the global awareness, and that is teachers and students can connect with Maple users over the globe through Maple primes. Global collaboration. I think the experience fosters adaptability, effective communication, creative problem solving, and technological proficiency, as well as cultural empathy. Also to note that global awareness builds the capacity for future global collaboration. This is because students begin to develop an appreciation for the differences among cities, towns, and countries across the globe in terms of how we view and function with mathematics. Here I want to introduce a framework for technology integration, which in mathematics enables educators to craft powerful collaborative learning experiences that support problem solving and flexible thinking. This TPAC model, that is, which is technological pedagogical content knowledge, is a method math faculty can use to analyze the effectiveness of technology integration. The framework itself, presented on this slide. For this model, instructors can take into account what is considered the technology knowledge the students will need, the mathematics content knowledge they will need, the best practices for teaching both the technology and the math, which is a direction in which I'm going with this webinar. Here, the model supports careful educative reflection on pedagogy, content, and technology, not only as separate entities, but as overlapping and intersecting domains, as you can see in the model. It also suggests that pedagogy, content, and technology are not mutually exclusive. In fact, the intersection of all three in this TPAC model is an intricate combination to obtain innovative teaching and learning. This is important because, without it, the technology may be integrated in a way that is pedagogically inappropriate for mathematics instruction. So through the Maple learning environment, mathematics faculty can achieve technological, pedagogical content knowledge, and hence achieving the transformational teaching and learning in the mathematics classroom. So next I'll discuss, our implementation process using Maple at our college and across our state in North Carolina. So the purpose for the implementation of Maple at Johnston Community College, which is where I work, is ultimately to improve student success in calculus. Maple's its computational engine and dynamic graphical capabilities, it improves faculty efficiency and simplifies difficult concepts when teaching math. So I have used Maple from pre-calculus all the way through calculus 3 of the past decade, as mentioned, and I've achieved remarkable success among my students. With the success generate excitement, and the reality is I wanted my colleagues to get just as excited as I was and achieve these kinds of results using this technology in their classroom. So in retrospect, I experienced more failures though than success, attempting to increase integration of Maple on our math classes on my own, that is. I expected quick results, and that's because it only took 15 to 20 minutes for me to realize how important Maple is and how it would eventually transform my teaching in the classroom. So as quickly as I learned to use Maple, just spending tremendous amount of time working through and navigating the software and utilizing the various resources out there. I held local sessions at my college, with peer-to-peer training workshops where faculty received professional development for attending these workshops. But the format, it was like one teacher expert presenting to my colleagues attending as learners, and often that can be intimidating, especially if I'm presenting as I learn. So with my excitement, and this is my excuse, that is just I was wanting to present everything that I was doing. So scaffolding is also important, and it's an important skill when we teach at any level. And what I really wanted to do is just to show to my colleagues just how awesome the software is, and in demonstration, and how the demonstrations has really impacted student learning. But all this was under certainly an assumption, that is my colleagues shared similar beliefs about the use of Maple in my actual classroom. So, as a department grew, it became increasingly more difficult to increase the use of Maple across the discipline. So a book by Adrian Alcazar on how colleges change, talks about the different types of change, and that this type of change is considered a second order change. And this process is, so substantial that it alters the operating systems, underlying values and culture of the organization. I realized the implementation of this type of technology required deep cultural change. According to Kizar, sense making is an approach for creating this kind of change. And sense making is ultimately changing mindsets. And as we know, it's very difficult. Kizar also suggests that sense making happens in two ways. One, individuals attach new meaning to familiar concepts and ideas. For example, the idea of an expert math faculty, one with strong content knowledge and pedagogical knowledge, versus the instructor or faculty who uses technology in a more sophisticated way to enhance teaching and learning. Additionally, it also suggests through sense making, people develop new language and new concepts. So this implies, in my perception, the use of the Maple integration just on a day-to-day basis for teaching and learning in our math classroom. That's huge change, especially for faculty who have been teaching for several years and are on the verge of making this kind of change. So the Maple support staff has been just phenomenal in what I perceive as just a planning and implementation phase for just really what I consider more professional training for faculty. So we planned and coordinated training beginning in the fall semester of 2018. And this just a tremendous amount of coordination and planning, talking about some of the experiences that are prior uses of Maple at my college and some of the challenges, and also really some statewide initiatives and goals as well. In doing so, we reached out to our 58 community colleges in North Carolina. 17 were responsive and were invited to participate in statewide training via Zoom. So the sessions were scheduled and held from January 2019 through to February 2019. And this just, gives it an idea of how it was conducted at my college. So as you can see, all faculty, who attend the session, which are full-time and part-time, math faculty, they all had access to Maple on either a school-issued, laptop or their personal devices in a low room with a large display. In retrospect, also, I would prefer a much larger display, but it still worked well, while other faculty across the community college system were either in a similar setup or at home, because you could essentially join in via Zoom just as you are right now. So the sessions, they lasted approximately 1 hour, and recordings and Maple files were available after each session. These were stored in our learning management system, which was Blackboard, and they were also made accessible to all the math faculty, so they can go back and review this at any time as they want to implement some of those topics addressed in their classes. As you can see, they range from Calculus 1 to differential equations, but we did take time to look at, session 1 was really, getting to, familiar with the Maple interface. So because we send the training across the state, we didn't want to assume that all participants have used Maple before. So that was only true to the participants at Johnston Community College. So session 1 was important to get everyone familiar with the Maple interface. And then onward, session 2 covered topics, in Calculus 1 through Calculus 3, session 3, linear algebra, and 4 differential equations. So following this, the training sessions, it was important, to have follow-up and see how faculty will improve the use of the software within the classroom. So certain things I observed is that faculty became more confident using Maple. They're certainly more effective at troubleshooting the classroom, which often was a challenge prior to having this level of training. Student confidence in instructors increase, as they become more confident in themselves as a user, and that's just an important fact. Instructors analyze students' conceptual understanding more effectively. We started doing more formative assessments, and throughout their calculus sequences, specifically Calculus 1, which were administered on a semester-to-semester basis, just to assess students' use of the technology in calculus. We also increased utilization of the software across our upper level math courses, and that is our calculus sequences, linear and differential equations, and the laboratory portions of the actual courses. So, our instructors, provide various perspectives in terms of their use. So they're very they're very excited about the support that was available and not receiving everything from one person. They certainly value what the Maple support team, has done and continue to do. The support and professional development provided the math faculty, provided to the math faculty at my college was really phenomenal. Many thanks again to Karishma Pinwani and Yogan Tulab. They did an exceptional job in just coordinating the whole efforts and conducting the training. So the professional development was well received, by the actual faculty at my college. So, following that, just talk about really how it's, across the board what we're doing now in addition to the support from MapleSoft. We faculty now schedule boot camps at the beginning of each semester. And these are tutorials designed to help students become familiar with Maple environment and teaching fundamental concepts and tools they need to become, productive quickly. So this is something they never did before the training, and we once made aware of it. This was really great because they've realized that don't necessarily have to do everything on their own. So with careful planning and coordination, you can schedule these trainings ahead of time and have the chime in via Zoom and just provide this introduction to the students. As long as I've been using Maple, I do use the boot camps and schedule them in my classes within the first week to give the students that perspective from expert users. These boot camps could last approximately 30 minutes, and again, they're done via Zoom. The faculty also schedule boot camp sessions ahead of time throughout the semester. So it's not just to introduce Maple to the students. This was a great opportunity for the faculty to just have a topic that they may not be very comfortable with teaching using Maple to be taught by or delivered by or introduced by an expert MapleSoft representative. We also had follow-ups and have opportunities for Q&A, and that's where the faculty would teach in various disciplines just to provide some content-specific questions, and we pose them to the support staff and scheduled Zoom sessions to address some of those, again, content-specific questions. We also, are grateful for the Maple Companion app, which is also a great tool for students and instructors. While students gain confidence in math, they can use this app for homework assistance in many of their undergraduate math classes. As a Maple user, you can use the Maple Companion app to bring math that is right in front of you into Maple. And you simply just take a screenshot of a problem. You can interact with it in the application or send it through Maple Cloud and pull it down to Maple and just use this to solve, visualize, and explore with the math. In instruction, we found it very useful because this particular app can be used to minimize the transcription errors. And I think I've mentioned that before. Use this app, it saves tremendous amount of time and minimizes student frustration. We also can use the Maple Primes. I think is a great way for, again, faculty and students to connect across the globe, and a great resource as well because students and faculty can pose questions for expert Maple users who are quick to provide a response, or through Maple Primes, you can even search for things that you're unaware of and use those to enhance your teaching in the classroom. So, follow up with our students or faculty and students often have an opportunity just to hear how things are going. So it's definitely how one of our seasoned math instructors, it shared some great things that are going on, some great experiences she has had using Maple in her classroom. One said with Maple, students are relieved from the pressure of computations and they're able to focus on demonstrating understanding of the concepts. she also mentions the idea of, or concept consolidation. So Maple allows her to evaluate a student's understanding of the calculus concepts, enabling the student to bypass potential algebra and, computational issues. So in Maple, it improves, the procedural knowledge while focusing on conceptual understanding. I think it's important as, users in the math classroom, just to, separate some of those issues you learn in mathematical concepts. If you're teaching calculus, you're thinking they really don't understand, let's just say, derivatives per se. Well, what is it about derivatives they don't understand? You can use Maple to just simply address that. Do you understand conceptually what it means by a derivative, by presenting that in a variety of ways using the software? Because it could be very well some deficiencies in the algebraic process, which certainly can be determined just by looking at the work they produce to you, but far more efficient, I believe, using Maple. And Stephanie Hall, she now teaches primarily her Calculus 2 courses, and certainly it's enhanced the classroom experience for her students using Maple, again, with just a variety of visualization features. I'm just toggling through. So with students, which is really is important, we want to find out how are students then, receiving this information. What are their perception of the increased use of Maple within the classroom? Well, I had one to share that, of course, he likes the way Maple operates with derivatives and integrals, and it says, of course, it's better than any calculator or software it's used. And students like, what I see that they really like the stepped out procedures in Maple. They find that very, very valuable, and it's often, I think, one of the greatest challenges when trying to encourage faculty to utilize Maple within the classroom as well. It does all the work for the students. Well, I mean, to some degree, I wouldn't say all, it just depends on the user. And often we realize there are deficiencies in any computer algebra system. But what's more important is that how can we utilize this technology in the best way to enhance the way students learn mathematics. So with the stepped out procedures, students can learn the process of analytically evaluating a limit. So are we factoring, we're rationalizing, and see what that does as we go from step to step. And while it may produce the solution to the first, second, or third problem, then students, that also deepens their understanding of the process, and then that helps them better understand, gives them more direction, I would say, in terms of what they're ultimately trying to achieve. Really, one of the most powerful things to find is the visualization features of Maple, especially when you're moving more into, well, even with Calculus 1, I think the calculus is very dynamic. So visualizations and animations, you present the calculus in a more dynamic way and not very static. So they realize that things are constantly changing, and when they really get the principle, the math is much more meaningful, the calculus is much more understandable. In Calculus 2 through Calc 3, when you start dealing with more of the three-dimensional surfaces, that's that's a very challenge, because we're expecting students, without any kind of technology, if we chose not to use them, to really visualize three-dimensional surfaces in their heads. And we're assuming that every student possesses that kind of spatial ability, when that may not necessarily be true. So with Maple, with very easy and efficiently, the clickable features just are in the context panel, especially in new versions of Maple, you can simply just produce a plot in a matter of seconds and rotate and interact with the plot to understand features of your surfaces. So great tool, I think, especially when we study extrema, using Maple for surfaces, as it is found very useful and just really deepens students' conceptual understanding through visualization. So just really, I think, there's so many great ways to think about how we can utilize the software as we present various topics in calculus to our students. And finally, I would like to end, with just saying that, with Maple in the hands of motivated and skilled faculty, say teaching mathematics, can be transformational. Improving the technological, pedagogical content knowledge and technology literacy of faculty, the use of Maple in the 21st century mathematics classroom, I think will have the greatest impact on student learning.